Hi everyone, today we're going to be exploring properties of parabolas. We're also going to be graphing quadratic functions in standard form. For the warm-up it says give the coordinates of the image of -5, 3 after each reflection. So I first have a reflection in the y-axis. Let's just pretend that we're plotting -5, 3. That would be somewhere over here. And if I'm reflecting it over the y-axis, it's going to flip over here. So you can see how that movement is horizontal, which is why another name for reflection in the y-axis is a horizontal reflection. For horizontal reflections, we take the x values and multiply by -1. So if I take -5 and multiply by -1, I would get +5. All right, if I'm doing a reflection in the x-axis, again, let's plot the point -5, 3. This time I'm reflecting or flipping over that x-axis. So the point's going to go down here. And you can see how it's vertical movement. So another name for reflection in the x-axis is vertical reflection. In that case, I'm going to be taking the y value and multiplying by -1. So the y value was 3 before, and now the y value would end up being -3. The next warm-up is a challenge question. So if you don't quite grasp it, don't be too hard on yourself. It's meant to feel challenging. It says, write a rule for G described by the transformations of F. Write your answer in vertex form, then identify the vertex. How would you find standard form? So I start with this function, x plus 6 squared plus 2. We first want to do a horizontal shrink by a factor of 1/3. Because it's horizontal, we're going to replace with x with something inside parentheses. And remember, horizontal shrink is weird, so I'm going to use the reciprocal of 1/3. So we have f of 3x. So everywhere I saw an x before, I'm now going to replace with 3x. So we'll have 3x plus 6 squared plus 2. Okay, and really, I can rewrite it just a little bit more simplified without that extra set of parentheses. Okay, then I do a translation 2 units up. So number 2 is a translation 2 up. Because it's vertical movement, I'm just going to put the +2 outside of parentheses. So for number 2, we'll have 3x plus 6 squared plus 2. Then I put the +2 outside parentheses. So it becomes 3x plus 6 squared plus 4. Okay? And last but not least, we have a reflection in the x-axis, which that is a vertical reflection. So the negative is going to go outside of the parentheses. Okay, so for number 3, we have a negative outside of parentheses because it's a vertical reflection. And I'm just going to copy everything I got in step 2 right inside the parentheses here. Okay, so if I distribute that negative through to the first leading coefficient, that would become -3x plus 6 squared, and distribute the negative to the 4, we would get -4. Now, that's not quite finished yet. While that is, in fact, in vertex form, I don't like how there's a leading coefficient of 3 here. I can't clearly see the left-right shift. So in order for my vertex form to be the best that it can be, we're going to factor out that 3. If I take 3x and I divide it by 3, what's left? X. And if I take 6 and I divide out the 3, I would be left with 2. So that would be the best answer. Negative, parentheses, 3, parentheses, x plus 2 squared minus 4. Here I can clearly see the vertical reflection, the horizontal shrink by 1/3, left 2, and down 4. Because I'm moving the graph left 2 and down 4, my vertex would be -2, -4. All right. The last part of that warm-up asks you, how would you find standard form? You would just completely expand it or multiply it out. So you'd actually have to FOIL this inner part that's being squared. All right, notes. It says an axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. Okay, so an axis of symmetry is the line that makes the image symmetrical. So like if I had a butterfly, the axis of symmetry would be this line right here. You'd want it to be completely symmetrical. Okay, it says because the vertex is h comma k, the axis of symmetry is the vertical line x equals h. That's really important to know that the axis of symmetry passes through the vertex. So if the vertex has an x value of h, then the axis of symmetry will also have an x value of h. Look at this picture. See how this is h comma k, and this line is x equals h. Remember, vertical lines have the format x equals some number. All right, so looking at this first example, it says graph -2 x plus 3 squared plus 4. We are going to go ahead and first set up our parent chart. So I have parent points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. I first see a vertical reflection, so I'm going to multiply all the y values by -1. So I get -4, -1, 0, -1, -4. Then I see a vertical stretch by 2, so then I'm going to multiply all the y values by 2. I'd get -8, -2, 0, -2, and -8. Then I see a shift to the left 3. So left 3, that's horizontal. I'm going to subtract 3 from all my x values. -2 minus 3 is -5. -1 minus 3 is -4. 0 minus 3 is -3, etc. So I'd get -2 and -1. Okay, and last but not least, I see this plus 4. That's a vertical translation up, so I'm going to add 4 onto all of my y values. So -8 plus 4 is -4, -2 plus 4 is 2, etc. I'd get 4, 2, and -4. Okay, notice I went from left to right so that my multiplication happened before my addition. You want to make sure you're following order of operations. Okay, as far as vertex goes, the vertex used to be at 0, 0. Now the vertex is going to be at -3, 4. And I could have known that just by looking at my original function. We went left 3, up 4, so my vertex should have been at -3, 4. Remember, the axis of symmetry should run through the vertex, so if the x value of the vertex is -3, then the axis of symmetry should have an x value of -3. Let's plot those points. We have -5, -4. We have -4, 2. We have -3, 4. We have -2, 2. And -1, -4. Okay, so this is what my parabola looks like. And my axis of symmetry is the line x equals -3. So this is my axis of symmetry right here. Okay, and if you see AOS, that's my abbreviation I use for axis of symmetry. It does divide the graph into 2 symmetrical parts. So these are just some student practice where we're going to graph the function, label the vertex, and do the same thing with the axis of symmetry. You can pause this video and try it on your own. Welcome back. So the first thing I want to do is write my parent points that I'm going to transform. I first see a vertical reflection, so that's going to change the y value. Multiply those by -1. I then see a vertical stretch by 3. Again, that's going to change the y values, so we multiply all the y values by 3. Okay, then I see an x plus 1, which is a shift left 1. That's going to change my x values horizontally. I'll subtract 1 from all my x values. Okay, so let's go ahead and graph those points. -3, -12 will go a little bit off my graph. We have -2, -3. We have -1, 0. And we have 0, -3. And then again, 1, -12 will go off my graph. So. Okay, so that's an idea of what that function looks like. The vertex, again, vertex is the highest or lowest point on your graph, so it's going to be -1, 0. I can also see the -1, 0 in the middle of my chart here. I could also see that there was a shift left 1 and then up and down 0 from my original function. The axis of symmetry should be the same x value as your vertex, so it should be x equals -1. Which hopefully if you graph x equals -1, it runs right through the middle of your parabola. Okay, the next one here, again, start with your parent points. Okay, we start with a vertical stretch by 2, so it changes all the y values. We multiply them by 2. Then we have a shift right 2, so I'm going to add 2 onto all my x values. Then I have a shift down 5, so I'm going to shift my y values down 5 units. Okay, so I can graph that. We'd have 0, 3. 1, -3, 2, -5, 3, -3, 4, 3. Make your nice U shape, no sharp edges. Okay, I can see that the lowest point on my graph is right here at 2, -5, so that's my vertex. I also would have known that 2, -5 was my vertex from the chart, or we can see the right 2 down 5 shift from my original function. If the vertex has an x value of 2, then the axis of symmetry should also have an x value of 2. So x equals 2. That line should be nice and straight. All right, quadratic functions can also be written in standard form. So I'm going to show you how you can derive standard form just by expanding or multiplying out the vertex form. Because I see x minus h squared here, I'm going to write the x minus h twice, and I'm going to FOIL it out. Okay. For now, we'll leave a alone. So this would become x squared minus hx plus h squared plus k. We'll combine the like terms in the middle. So really we have 2 of those hx terms. Now I'm going to distribute the a through to each of these 3 terms. So we'll have ax squared minus 2a hx plus ah squared plus k. Okay, and now it's starting to resemble standard form. It's just kind of yucky looking. Remember, standard form is ax squared plus bx plus c. So notice a is just a, right? So the a in the vertex form has the same meaning as the a in standard form. A equals a. For b in standard form, b has the same meaning as -2 ah. B in standard form has the same meaning as negative 2AH from vertex form. If I want to get H by itself, we would just have to divide both sides by negative 2A. And so I would get negative B over 2A. Why is H so important here? Think back to why H was important in vertex form. What did H represent in vertex form? H gave you the x value of your vertex, right? So we want to know how to get the x value of your vertex in standard form. So how I find the x value of my vertex in standard form is I use negative b over 2a. The axis of symmetry would then end up being x equals negative b over 2a, because if this is the x value of your vertex, then that same x value should be used for your axis of symmetry. And what is C equal to? Remember, in vertex form, we had ax minus h squared plus k. And notice that if I plug in 0 for x, do you see how I'd end up with ah squared plus k? That's what I had right here. Do you see how C from standard form is the same as ah squared plus k from vertex form? So C is going to end up being the y-intercept. Remember, y-intercept can be written as 0, c. So again, if you don't completely understand that, it's not a big deal. I just want to show you that the two forms are related. Here's what you need to memorize. Okay, so this is important to memorize. The steps that you're going to use to graph ax squared plus bx plus c. Okay, you are not going to use transformations to graph standard form. I'm going to say that again. You're not going to use transformations to graph a quadratic function in standard form. Instead, you're going to follow these 5 steps. 1. Identify A, B, and C. 2. Your axis of symmetry is going to always be x equals negative b over 2a. Okay, that's just something you memorize. Okay, so I would take the b value and the a value and use negative b over 2a to get the axis of symmetry. The vertex is one of the points on the axis of symmetry. Therefore, the x value of the vertex is also negative b over 2a. Okay, so how do I find the y value of the vertex? Once I know the x value of the vertex, you're going to plug in your x value into your function to find the y value of your vertex. Okay? How do you write the vertex using function notation? Well, the x value of your vertex is negative b over 2a, and in order to get the y value, I would have to plug in x. So I'm going to do f of negative b over 2a. Okay? How do I find the y-intercept? Remember, the y-intercept is just your c value, right? If I plug in 0 into my function, I can simplify to get c. Okay? For any time you're asked to find the y-intercept, you plug in 0 into your function for x. Okay? And then the last step is going to be to graph the mirror point for the y-intercept. All right, so let's see this in action. Again, just another review picture. You can see in this review picture how the axis of symmetry is negative b over 2a. You can see how the y-intercept is 0, c. All right. The negative in front of a is still going to represent a vertical reflection and cause a flip. The a value still is the vertical stretch or shrink, but b is different in standard form B determines the axis of symmetry and the x value of the vertex. Okay, memorize this negative b over 2a. And then the c value represents the y-intercept. So here's a function in standard form. We're going to go through each of those 5 steps together. Okay, so the first step, remember, was to identify a, b, and c. Okay, so what is a? A is equal to 3. B is equal to -6, and C equals 1. Step 2, let's take a look. I did number 1. Step 2 is to find the axis of symmetry, and we use -b over 2a. So opposite b over 2a. X equals opposite of b. What's negative b? What's opposite of -6? Positive 6. Over 2a. And what's a? A is 3. So I end up getting 6 over 6, which is really just 1, right? So the axis of symmetry is x equals 1. All right. Then to find the vertex, it says the x value of the vertex is -b over 2a. Remember, the vertex is on the axis of symmetry. So I already know the x value of the vertex. How do I find the y value? Think about when we were solving systems of equations. Like we would solve the system, blah, 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 blah. We would get x equals 1, and then what would I have to do to get the y value? I'd have to plug that back in order to get the y output. All right, it's no different here. Once I know that x is 1, I just plug 1 back into my function in order to get what the y output is. F of 1 equals 3 times 1 squared minus 6 times 1 plus 1. So that would be, do your exponent first, 3 times 1 minus 6 plus 1. What's 3 minus 6 plus 1? That would be -3 plus 1 or -2. Okay, so the vertex is 1, -2. See? How do you find the y value of the vertex? We just plug in the x value. Okay. Then it says, how do you find the y-intercept? Remember, to find a y-intercept, we plug in 0 for x, solve for y. It's also the c value. Okay, so if I want to find the y-intercept, we'll go ahead and just add this in here. If I plug in 0 for x, what would that be? 3 times 0 squared minus 6 times 0 plus 1. 0 times anything is 0, so see how you're only left with the c value? When I plugged in 0, I got 1. Okay, so I'm going to graph the vertex, 1, -2. I'm going to graph the axis of symmetry, which should go right through the vertex. There's the axis of symmetry. I'm going to graph the y-intercept, 0, 1. Okay, so that's what I've got so far. And remember, my last step, once I get the y-intercept, is to graph the mirror point of the y-intercept. That's going to help you get the width. So if I mirror this point, or if I reflect it across the axis of symmetry, I would get this point right here. See how that gives us a width of the parabola? That's what I want. Okay, so we're just going to try this a couple more times so you can get the hang of it. Again, the first thing I do is I label A, B, and C. Here A is 1, B is 2, and C is -1. I then find the axis of symmetry. Remember, axis of symmetry is -b over 2a. So what's opposite of b? B was 2, so I'm going to put -2 over 2a. A was 1. So I get -2 over 2, which reduces to -1. So the axis of symmetry is x equals -1. Remember, the vertex is going to share that same x value since it's on the axis of symmetry. And I'm just plugging in -1 up here into my function in order to get the y output. H of -1 is going to be -1 squared plus 2 times -1 minus 1. Okay, h of -1 equals So it's going to be 1 minus 2 minus 1, or what would that be? Negative 1 minus 1, which is negative 2. Okay, so it looks like it would be negative 1, negative 2. So let me graph that. Negative 1, negative 2 is my vertex. Axis of symmetry goes right through it. There's x equals negative 1. And then how am I going to find the width of my graph? What do I still need? I still need the y-intercept. Remember, the y-intercept is just the c value, 0, negative 1. Okay, another way to find the y-intercept is to plug in 0 for x, right? If I plug in 0 here, that term would go to 0. If I plug in 0 there, that term would go to 0. And all I'll be left with is negative 1. So 0, negative 1 is my y-intercept. And then I'm going to mirror that across the line of reflection, or the axis of symmetry. Okay, and so I'm going to get this mirror point right here. And then I can draw in my U shape. There we go. All right, last but not least, again, identify your A, B, and C value. Here my A value is negative 2, my B value is negative 8, and my C value is 1. Then I find the axis of symmetry. That's negative B over 2A. What's opposite of negative 8? Positive 8 over 2A. A is negative 2. So I get 8 over negative 4, which is really negative 2. So my axis of symmetry is x equals negative 2. Remember, the x value for the axis of symmetry is the same as the x value for the vertex. And in order to get the y value of the vertex, I just have to plug in negative 2 up here into my function. So p of negative 2 is going to be negative 2 times negative 2 squared minus 8 times negative 2 plus 1. I'm running out of room. And if I go ahead and plug all of that information in, I think you end up getting 9. Right? I would just plug that into your calculator and press enter. Just exactly how it is, plug it in, you get 9. Okay, so let me graph that. We have negative 2, 9. The axis of symmetry runs right through that vertex. Okay, and then how do I get the width of my graph? What am I still forgetting to do? I need to find the y-intercept. To get the y-intercept, I plug in 0 for x. If I plug in 0 for x, this term will go to 0. If I plug in 0 for x here, that term will go to 0. And so really my c value, 1, will indicate my y-intercept for me. So I have 0, 1. And then I reflect that across the axis of symmetry. So see how this is a distance of 2 away from the axis of symmetry? I want to go a distance of 2 away here and put my mirror point. All right, and then connect those points in order to get your parabola. Perfect. There you go.